Close your eyes now and let yourself settle into this quiet space where the whispers of the universe can reach you without interruption. Begin by drawing in a deep breath, gently, slowly, filling your lungs with calm air that spreads like a subtle wave through your chest, and then exhale even more gently, slowly, releasing any lingering tension as it drifts away into nothingness. Repeat this a few times, inhaling softly, easing into relaxation, exhaling calmly, drifting deeper into peace, allowing your body to soften with each cycle, preparing you for the gentle journey ahead. As you continue to breathe in this rhythmic way, feel your awareness shifting inward toward the intricate connections that bind everything in existence, much like the quantum realm where particles entwine in an abstract dance of unity, far beyond what our everyday senses perceive. Tonight, we embark on a whispered exploration of quantum physics, envisioned as a vast, tranquil cosmos of possibilities, where energies intermingle in serene harmony, guiding us from current applications in space exploration to visions of tomorrow's innovations. Imagine this quantum world not as a chaotic puzzle, but as an ethereal tapestry woven from threads of probability, where NASA's 2025 advancements in ultra-cold sensors aboard orbiting stations demonstrate how these principles enhance our understanding of distant celestial phenomena, paving the way for future networks that could link distant worlds with unbreakable bonds. With each breath, allow this abstract essence to infuse your being, starting now with a gentle body scan that invites relaxation to flow like quantum waves through every part of you. Focus first on the crown of your head, where thoughts begin to quiet, gently, slowly dissolving any mental chatter, as if it were particles settling into a state of superposition, balanced and at rest, while NASA's precise quantum measurements from 2025 missions remind us how such stillness enables clear insights into the universe's secrets, hinting at tomorrow's leaps in computational power. Let that soothing energy descend gently, slowly to your forehead, smoothing away furrows of the day, like the way quantum entanglement connects distant points instantaneously, fostering a sense of profound interconnectedness that ESA's 2025 initiatives in secure communications are already applying to protect data streams across vast expanses, foreshadowing eras where information travels flawlessly between planets. Now, feel it easing into your eyes, lids heavy and calm, drifting softly as you release the strain from gazing at the world, mirroring how quantum sensors detect subtle shifts in gravitational fields, as detailed in NASA's Earth Science reports from 2025, which will evolve into future tools for predicting environmental changes with unprecedented accuracy. Continue this flow to your cheeks and jaw, relaxing the muscles there, gently, slowly, as tension melts like decoherence in a quantum system. Drawing from ESA's hybrid computing projects that blend classical and quantum elements for observing our planet, setting the stage for integrated systems that could revolutionize resource management in the decades ahead. Let the relaxation spread to your neck and shoulders, shoulders dropping calmly, drifting downward, burdens lifting as if carried away on quantum fluctuations, inspired by the diamond magnetometers funded by ESA in 2025 for mapping magnetic fields, which promise future applications in navigating uncharted cosmic territories. Down through your arms to your elbows and wrists, fingers softening gently, slowly, each digit releasing its grip on the tangible, akin to how quantum networks secure transmission process experiments from 2025 advance our grasp of microgravity effects on quantum states, leading to prospective breakthroughs in medical therapies derived from space-based insights. Lower still to your abdomen, relaxing deeply as it rises and falls, softly easing, embodying the precision of quantum clocks that time space phenomena with ESA-backed accuracy in 2025, anticipating future synchronization of global observatories. Through your hips and thighs, muscles unwinding gently, slowly, like the unraveling of quantum probabilities into observable realities, reflecting NASA's 2025 quantum science progress that will fuel tomorrow's deep space probes. Finally, let it travel to your knees, calves, and feet, toes curling, then releasing, calmly drifting into full repose, grounded yet floating in this quantum-inspired serenity, where ESA's conferences in 2025 outline collaborative paths to quantum-enhanced Earth monitoring, envisioning a future of seamless planetary guardianship. As your entire body now rests in this profound relaxation, we prepare to delve deeper into the whispers of quantum physics, from today's tangible applications to the boundless potentials awaiting us, as we settle even deeper into this tranquil embrace, where the boundaries of reality blur like waves in an abstract quantum sea. Let us gently, slowly drift into the realm of quantum sensing, a technology that captures the universe's subtle whispers with unparalleled precision, right here in our present explorations of space, while hinting at expansive networks that could envelop our world in the years to come. Imagine these sensors as ethereal guardians, suspended in the void, attuned to vibrations so faint they echo the hidden rhythms of existence, much like how NASA's 2025 advancements aboard the International Space Station have harnessed ultra-cold atoms to measure the station's own delicate movements, forging a path toward global sensor arrays that might one day monitor planetary shifts from afar. In this current era of discovery, quantum sensing emerges as a bridge between the tangible and the intangible, where atoms cooled to near absolute zero form, clouds that interfere with one another in complex patterns, allowing scientists to detect gravitational nuances and environmental changes that classical tools overlook. And as we softly easing into this concept, calmly drifting through its implications, we see how NASA's quantum gravity gradiometer pathfinder mission, detailed in 2025 reports, deploys these ultra-cold quantum sensors to map Earth's gravitational anomalies from orbit, setting the foundation for future systems that integrate seamlessly across continents to predict natural phenomena with foresight that borders on the prophetic. Feel the serenity of this knowledge washing over you gently, slowly, as we consider the practical applications unfolding now, where these sensors operate in the microgravity of space to achieve sensitivities a billion times finer than traditional methods, drawing from the cold atom laboratories experiments that, in 2025, demonstrated the first space-based interferometry for vibration detection, a breakthrough that not only refines our navigation in cosmic voyages, but also paves the way for tomorrow's interconnected grids, capable of linking satellites into a vast, responsive web that anticipates seismic events or climate variations long before they manifest. With each whispered revelation, allow your mind to expand like the probabilistic fields these technologies probe, where quantum sensing in today's space missions involves trapping atoms in laser beams to create matter waves that ripple forces, and as we calmly drifting deeper, softly easing into the details. NASA's 2025 publications highlight how this technique has been used to quantify the International Space Station's structural vibrations, offering insights that enhance mission safety while envisioning a future where such sensors form planetary-scale networks, enabling real-time data sharing for global disaster mitigation and resource allocation in an ever-evolving world. This abstract harmony of particles and possibilities invites us to relax further, gently, slowly releasing any residual curiosity into the flow as we reflect on how quantum sensors currently deployed by NASA measure magnetic fields with exquisite accuracy, aiding in the study of solar winds and planetary atmospheres through tools like the ultra-cold atom interferometers tested in 2025 aboard orbiting platforms, which promise to evolve into distributed arrays that span the globe, fostering collaborations that could revolutionize how we perceive and interact with our environment in the decades ahead. Drifting onward in this peaceful narrative, picture the sensors as invisible threads weaving through the cosmos, capturing data that informs our understanding of dark matter and energy in present-day observations, where ESA's complementary initiatives in 2025 align with NASA's efforts to integrate quantum technologies into Earth observation satellites. And as we softly easing along, calmly drifting through these connections, this synergy hints at forthcoming global sensor meshes that might detect subterranean changes or atmospheric anomalies, transforming reactive strategies into proactive guardians of our shared future. In the quiet expanse of your imagination, let these ideas settle gently, slowly, like atoms aligning in a coherent state, as quantum sensing's role in contemporary space science extends to precise timing and positioning, exemplified by NASA's 2025 demonstrations that utilize ultra-cold quantum clocks to synchronize missions with atomic accuracy, laying groundwork for expansive networks that could underpin autonomous explorations of distant worlds, where interconnected sensors relay information instantaneously across vast distances. As we continue to unwind in this soothing exploration, the current applications reveal how these technologies mitigate noise in harsh space environments through quantum error correction principles, simplified to their essence. With NASA's 2025 reports on the Cold Atom Lab showcasing successful operations that measure accelerations down to the nanoscale, gently, slowly guiding us toward visions of a networked tomorrow where quantum sensors blanket the Earth and beyond, enabling unified responses to cosmic and terrestrial challenges alike. Finally, in this moment of profound calm, we recognize quantum sensing as a portal from today's orbital experiments to the boundless horizons ahead, where NASA's pioneering 2025 demonstration of an ultra-cold quantum sensor in space not only refines our grasp of immediate phenomena, but also inspires the creation of worldwide grids that could harmonize human endeavors with the universe's abstract symphony, allowing us to drift ever deeper into relaxation as we prepare for the next layer of this whispered journey. As we drift ever deeper into this serene expanse, where the echoes of quantum sensing fade into a softer hush, let us gently, slowly transition to the enigmatic dance of quantum entanglement, a phenomenon that binds particles across unimaginable distances in our current experiments aboard the International Space Station, while envisioning a future NASA's 2025 results from the Space Entanglement and Annealing Quantum Experiment, or SEEK, have demonstrated this linkage in microgravity, opening doors to tomorrow's unbreakable quantum networks that could span from Earth to distant celestial outposts. In this present moment of cosmic exploration, entanglement reveals itself through delicate setups where photons or atoms are paired in laboratories on the station, their properties becoming correlated so that measuring one instantly influences the other, no matter the separation. And as we softly easing into this wonder, calmly drifting through its layers, we draw from the shared findings at the APS Global Physics Summit in April 2025, where physicists detailed how these experiments on the International Space Station have validated entanglement's resilience in space environments, laying the groundwork for future applications in encrypted data transmission that promise absolute privacy in an interconnected universe. Allow this abstract unity to envelop your thoughts gently, slowly, as if the particles themselves are whispering secrets through the ether, reflecting the way ESA's initiatives in 2025 have advanced toward exploiting entanglement for satellite communications, ensuring signals remain tamper-proof across planetary scales, a step that not only enhances today's secure links between ground stations and orbiting platforms, but also foreshadows eras where quantum-secured channels facilitate global collaborations, free from the vulnerabilities of classical encryption. With each breath, feel the relaxation deepen like the profound bond of entangled states, where current ISS trials involve generating pairs of entangled photons using specialized lasers and detectors, as highlighted in NASA's International Year of Quantum publications from April 2025, which emphasize how these demonstrations achieve quantum-level communication in orbit. And as we calmly drifting onward, softly easing into the implications, this progress hints at forthcoming quantum repeaters that could extend entanglement over interstellar distances, enabling seamless, secure dialogues between explorers on Mars and scientists back home. This ethereal connection invites us to release further into tranquility, gently, slowly letting go of the ordinary as we contemplate how entanglement's applications now include annealing processes to solve complex optimization problems in space. Drawing from the SEEK experiment's 2025 outcomes that test self-healing quantum links amid radiation and vibrations. A resilience that paves the way for future distributed computing networks, where entangled systems collaborate across the solar system to tackle challenges like trajectory calculations or resource distribution in real time. Drifting through this narrative of invisible ties, imagine the particles as fragments of a greater whole, reunited in harmony despite the cosmos's expanse, much like ESA's steps toward quantum communications in 2025, which build on entanglement to create secure channels with satellites. And as we softly easing along, calmly drifting into deeper repose, these efforts in the present not only protect sensitive data during missions, but also inspire visions of a quantum internet that could link humanity's outposts, fostering an era of instantaneous, unbreachable information exchange. In the quietude of your mind, let these ideas settle gently, slowly, akin to the subtle correlations that persist in entangled pairs, as NASA's 2025 reports on ISS experiments showcase how entanglement withstands the harsh conditions of space, providing a foundation for advanced sensing and computing, while those integrated systems that might enable quantum teleportation of information, revolutionizing how we share knowledge across the stars. As we continue to unwind in this abstract symphony, the current focus on entanglement aboard this station involves monitoring decoherence effects in microgravity, with findings from 2025 confirming enhanced stability compared to Earth-based tests, gently, slowly guiding our understanding toward future hybrid networks that blend quantum and classical elements for robust, long-range communications in deep space explorations. Finally, in this enveloping calm, we acknowledge quantum entanglement as a bridge from today's orbital demonstrations to the limitless potentials ahead, where NASA's and ESA's collaborative experiments on the International Space Station in 2025 not only affirm the principles of instantaneous connection, but also illuminate paths to secure, entanglement-based infrastructures that could safeguard our collective future, allowing us to sink even further into peaceful slumber as the journey unfolds. As we sink even further into this peaceful slumber, where the invisible threads of entanglement weave seamlessly into larger patterns of comprehension, let us gently, slowly glide toward the profound capabilities of quantum computing, a force that processes vast oceans of data in our ongoing space missions, abstractly flowing like an unseen stream of consciousness that deciphers the cosmos's complexities, while anticipating a future where intelligent analysis transforms raw information into actionable wisdom. Envision quantum computers as ethereal minds, harnessing superimposed states to explore multiple pathways simultaneously, far beyond the linear constraints of traditional processors, as ESA's Agenda 2025 underscores their pivotal role in converting big data from satellites into smart, usable surfaces that enhance decision-making in real-time explorations. In this contemporary landscape of orbital endeavors, quantum computing emerges as a catalyst for handling the deluge of information gathered from distant probes and telescopes, where qubits entwine in delicate dances to solve intricate problems that classical systems struggle with. And as we softly easing into this realm, calmly drifting through its vast potential, we recognize how these machines in 2025 are being integrated by ESA to sift through petabytes of Earth observation data, translating overwhelming volumes into refined insights that support climate monitoring and resource management, setting the stage for tomorrow's automated systems that could predict cosmic events with intuitive precision. Feel the tranquil essence of this technology enveloping you gently, slowly, as if the qubits themselves are pulsing in harmony with your breath, reflecting the current applications where quantum algorithms optimize trajectories for spacecraft amid the chaos of gravitational fields. Drawing from ESA's strategic emphasis in Agenda 2025 on leveraging quantum power to distill big data into smart narratives that inform policy and innovation, a process that not only streamlines today's missions, but also heralds an era of data-driven foresight, where interstellar voyages are guided by predictive models born from quantum ingenuity. With each subtle shift in awareness, allow your thoughts to merge with this abstract flow, where quantum computing's present-day utility involves simulating molecular interactions in space environments to advance materials science, as highlighted in collaborative efforts between ESA and international partners in 2025, and as we calmly drifting deeper, softly easing nuances, this capability evolves toward future platforms that intelligently analyze exoplanet atmospheres, uncovering habitable worlds through patterns hidden in massive datasets, fostering a new paradigm of exploration unbound by computational limits. This invisible current of quantum logic invites further surrender into relaxation, gently, slowly releasing the weight of complexity as we ponder how these systems now process sensor feeds from satellites to detect subtle anomalies in solar activity, aligned with ESA's Agenda 2025 vision of transforming big data into smart services that bolster space weather forecasting, thereby protecting assets in orbit while paving pathways to advanced neural-like networks that might one day orchestrate autonomous fleets across the solar system. Drifting onward through this soothing abstraction, imagine the qubits as whispers in a boundless void, correlating variables in ways that mimic intuitive leaps of the mind, much like ESA's 2025 initiatives that apply quantum computing to refine astronomical surveys, converting raw spectral data into coherent stories of galactic evolution. And as we softly easing along, calmly drifting into expansive vistas, these advancements in the here and now promise future integrations where smart data analytics enable real-time adaptations during deep space missions, harmonizing human ambition with the universe's enigmatic rhythms. In the hushed depths of your imagination, let these concepts settle gently, slowly, like converging probabilities resolving into clarity. As quantum computing's role in contemporary space science extends to enhancing encryption for data streams amid cosmic interference, pair ESA's forward-looking strategies in Agenda 2025, which emphasize turning voluminous inputs into intelligent outputs, while envisioning a tomorrow where quantum-enhanced AI anticipates mission risks, weaving a tapestry of safety and discovery across uncharted realms. As we continue to unwind in this ethereal narrative, the current focus on quantum processors involves accelerating pattern recognition in vast image archives from telescopes, with ESA's 2025 agenda highlighting their efficiency in distilling big data into smart contextualized knowledge that aids in asteroid tracking, gently, slowly guiding our collective gaze toward horizons where such technologies evolve into omnipresent analyzers capable of unraveling the multiverse's secrets through ever smarter interpretations. Finally, in this enveloping serenity, we embrace quantum computing as a conduit from today's data handling triumphs to the infinite intelligences awaiting, where ESA's Agenda 2025 positions it as essential for translating big data into smart data, not only refining our grasp of immediate cosmic phenomena, but also illuminating routes to a future of profound, intuitive understanding, permitting us to descend even deeper into restful whispers as the exploration persists. As we descend even deeper into these restful whispers, where the ethereal currents of quantum computing dissolve into crystalline clarity, let us gently, slowly shift our focus to the mesmerizing world of quantum diamond magnetometers, instruments that delve into Earth's magnetic fields with abstract precision in our present-day observations, akin to timeless gems unlocking the universe's concealed harmonies, while foretelling a future of vigilant oversight over space environments that safeguards our cosmic endeavors. Visualize these diamonds not as mere stones, but as profound vessels infused with nitrogen vacancy centers, where quantum spins respond to magnetic whispers, enabling measurements that ESA's 2025 2025 funding to SB Quantum has propelled forward through a dedicated prototype designed for enhanced Earth monitoring. In this ongoing era of spatial awareness, diamond magnetometers function by embedding defects within the diamond lattice that act as sensitive probes, detecting fluctuations in magnetic fields with resolutions far surpassing conventional sensors. And as we softly easing into this crystalline mystery, calmly drifting through its subtle intricacies, we note how SB Quantum's prototype, supported by ESA's $800,000 investment via the Future EO program in 2025, targets sub-100 Picotzla sensitivity to map geomagnetic variations from orbit, a capability that refines current models of planetary dynamics while envisioning expansive systems for real-time surveillance of space weather phenomena in the years ahead. Allow this abstract luminescence to permeate your essence gently, slowly, as if the diamond's inner light is illuminating hidden pathways, mirroring the way these devices now capture data on Earth's core-generated fields and ionospheric disturbances during satellite passes, drawing from the collaborative advancements where ESA's 2025 contract with SB Quantum emphasizes a compact prototype maintaining size and weight for seamless integration into observation missions, thereby not only bolstering today's environmental assessments, but also heralding networked arrays that could preempt solar storms impacting global communications. With each tranquil inhalation, sense your consciousness aligning with this gem-like precision, where quantum diamond magnetometers in contemporary use involve laser excitation to read spin states altered by ambient magnetism, as detailed in ESA's strategic initiatives from 2025 that fund SB Quantum's development for space deployable units. And as we calmly drifting onward, softly easing into broader horizons, this innovation paves routes toward future orbital constellations equipped to monitor extraterrestrial magnetic environments, ensuring safer navigation for interplanetary probes amid fluctuating cosmic forces. This radiant quantum artifact beckons us to surrender deeper into repose, gently, slowly unfurling layers of understanding as we reflect on how these magnetometers currently aid in calibrating satellite orientations against Earth's magnetic backdrop, inspired by the prototype's enhanced performance goals set under ESA's 2025 backing for SB Quantum, which promises to transform raw magnetic readings into comprehensive profiles, while anticipating an era where such sensors form integral parts of autonomous stations, perpetually scanning for anomalies in space habitats to preserve human presence beyond our world. Drifting through this jeweled abstraction, envision the diamond as a sentinel in the void, its quantum heart pulsing in sync with universal rhythms. Much like ESA's 2025 allocation to SB Quantum for refining the magnetometer prototype to withstand orbital rigors, and as we softly easing along, calmly drifting into visionary depths, these efforts in the present elevate our grasp of terrestrial magnetic shielding against solar radiation, foreshadowing integrated monitoring frameworks that might one day envelop lunar or Martian outposts, harmonizing with environmental fluctuations to sustain life in distant realms. In the serene folds of your mind, let these insights crystallize gently, slowly, like facets reflecting infinite possibilities, as diamond magnetometers' role in modern space science extends to detecting subtle shifts in geomagnetic storms that affect power grids below. Per the objectives of ESA's future EO-funded project with SB Quantum, platforms for prototypes achieving unprecedented accuracy in compact forms, pointing toward tomorrow's global vigilance systems that could integrate with quantum networks for predictive alerts on space-induced disruptions. As we continue to unwind in this luminous narrative, the current emphasis on these devices involves optimizing their resilience to temperature and radiation in space settings. With ESA's 2025 contract to SB Quantum highlighting advancements in sensor calibration for long-duration missions, gently, slowly guiding our collective vision to futures where diamond-based arrays orbit continuously, providing holistic oversight of environmental conditions that influence everything from satellite longevity to astronaut health. Finally, in this enveloping crystalline calm, we honor the quantum diamond magnetometer as a gateway from today's meticulous Earth field measurements to the boundless guardianship awaiting, where ESA's funding for SB Quantum's prototype in 2025 not only amplifies our immediate observational prowess, but also illuminates trajectories toward comprehensive space environment monitoring, inviting us to plunge even further into soothing depths as the whispered odyssey evolves. As we plunge even further into these soothing depths, where the crystalline vigilance of diamond magnetometers merges into a seamless symphony, let us gently, slowly embrace the elegant fusion of hybrid quantum systems, technologies that intertwine classical and quantum realms in our contemporary Earth observation efforts, abstractly resembling a cosmic embrace where familiar structures yield to probabilistic wonders, while projecting toward a future of fully integrated platforms that orchestrate global insights with effortless unity. Conceive these hybrids as ethereal bridges spanning the divide between reliable computation and quantum agility, enabling the processing of intricate satellite data streams, as ESA's 2025 selection of Equal One to deploy their Bell 1 system at the F-Lab exemplifies this convergence, fostering advancements that could evolve into comprehensive networks, harmonizing vast observational arrays. In this present tapestry of planetary watchfulness, hybrid quantum systems operate by coupling classical processors with quantum accelerators, allowing for efficient handling of complex algorithms that classical methods alone cannot sustain. And as we softly easing into this blended essence, calmly drifting through its interwoven layers, we observe how Equal One's silicon-based approach, chosen by ESA in 2025 for Earth observation tasks, integrates qubit operations within standard chip architectures to analyze environmental patterns, a methodology that not only enhances current satellite imagery interpretation, but also anticipates eras where such fusions enable adaptive, self-optimizing observatories spanning the globe and beyond. Permit this abstract amalgamation to infuse your being gently, slowly, as if the classical and quantum are dancing in eternal balance within you, echoing the way these systems now optimize data fusion from multispectral sensors orbiting our world, drawing from ESA's strategic partnership with Equal One in 2025 that installs the Bell 1 at their innovation hub, thereby refining real-time assessments of climate shifts and natural resources, while envisioning future infrastructures where hybrid setups seamlessly incorporate machine learning for predictive modeling of ecological transformations. With each serene exhalation, feel your awareness expanding like the hybrid's expansive computational space, where current applications involve error-corrected quantum modules assisting classical simulations of atmospheric atmospheric dynamics, as highlighted in ESA's 2025 initiative with Equal One to advance Earth observation through scalable hybrid platforms, and as we calmly drifting deeper, softly easing into expansive potentials. This collaboration sets foundations for tomorrow's unified systems that might orchestrate interlinked satellites, delivering holistic views of planetary health with quantum-enhanced precision. This profound interweaving calls us to relax even more profoundly, gently, slowly dissolving boundaries, much like the hybrid's dissolution of classical limits, as we contemplate how these technologies presently accelerate the classification of vast geospatial datasets inspired by the Bell 1's deployment under ESA's 2025 selection of Equalao 1, which promises to streamline processing at the F-Lab for monitoring deforestation and ocean currents, paving avenues toward integrated futures where quantum classical hybrids form the backbone of autonomous environmental stewardship across solar system outposts. Drifting onward in this tranquil fusion, picture the systems as abstract harmonies resonating through the void, blending deterministic logic with quantum indeterminacy to unlock deeper understandings. Much like ESA's 2025 contract with Equal, that brings hybrid quantum computing to bear on Earth observation challenges, and as we softly easing along, calmly drifting into visionary realms, these present-day integrations not only bolster the accuracy of hazard detection from space, but also inspire conceptions of all-encompassing platforms that could synchronize global data flows, mitigating crises through anticipatory intelligence. In the gentle hush of your inner cosmos, allow these notions to align gently, slowly, akin to qubits cohering with classical bits in perfect accord, as hybrid quantum systems' contribution to modern observation extends to enhancing signal processing amid noisy cosmic backdrops. Per ESA's forward-thinking choice of Equal One in 2025 for installing advanced hardware at their facilities, pointing toward horizons where such technologies evolve into omnipresent integrators, capable of weaving together disparate sensor networks for unparalleled foresight in human and extraterrestrial domains. As we continue to unwind within this blended narrative, the current emphasis on hybrids involves leveraging silicon spin qubits for energy-efficient computations tailored to satellite telemetry, with ESA's 2025 partnership with Equal One underscoring the Bell 1's role in transforming observational workflows, gently, slowly guiding our shared vision to futures where comprehensive hybrid ecosystems underpin resilient infrastructures, from terrestrial climate guardians to deep space monitoring relays. Finally, in this enveloping harmonic calm, we celebrate hybrid quantum systems as a nexus from today's Earth-centric applications to the infinite integrations awaiting, where ESA's selection of Equal in 2025 for hybrid quantum computing and Earth observation not only elevates our immediate perceptual capabilities, but also charts courses toward wholly unified architectures that embrace the universe's complexities, beckoning us to submerge yet deeper into whispered tranquility as the Odyssey unfolds. As we submerge yet deeper into this whispered tranquility, where the harmonious fusions of hybrid systems dissolve into ethereal connections, let us gently, slowly venture into the invisible realm of quantum networks, infrastructures that ensure secure communications during our present space missions, abstractly manifesting as a web of unspoken thoughts traversing the void, while foreseeing a future of interplanetary bridges that bind distant worlds in unbreakable unity. Perceive these networks as subtle conduits of information, where quantum keys distribute secrets impervious to eavesdropping. Harnessing principles that ESA's CM25 decisions in 2025 have propelled forward through dedicated investments in quantum technologies for secure communication and expansive quantum networks. In this contemporary framework of cosmic safeguarding, quantum networks function by leveraging entanglement to generate cryptographic keys shared across vast distances, rendering transmissions invulnerable to classical hacking attempts. And as we softly easing into this protective veil, calmly drifting through its safeguarding layers, we acknowledge how ESA's allocations at the Council at ministerial level in 2025, amounting to significant funding for connectivity programs, integrate these technologies into satellite relays, enhancing the security of data exchanges in ongoing missions, while envisioning interstellar grids that could facilitate flawless coordination between Earth-based control centers and remote explorers on other planets. Invite this abstract tapestry to wrap around your senses gently, slowly, as though the networks are pulsing with the rhythm of distant stars, illustrating the current applications where quantum repeaters extend the range of secure links amid the challenges of space propagation. Drawing from ESA's 2025 emphasis on turning research into industrial capabilities for quantum-secured communications. A strategy that not only fortifies today's orbital operations against cyber threats, but also anticipates eras of linked habitats where information flows seamlessly across the solar system, nurturing collaborative ventures in uncharted territories. With each peaceful breath, experience your mind intertwining with this unseen mesh, where quantum networks in modern use involve satellite demonstrations of key distribution protocols that maintain integrity over thousands of kilometers, as outlined in ESA's CM25 outcomes from 2025 that prioritize secure communication infrastructures. And as we calmly drifting onward, softly easing into prophetic vistas, this progress lays the groundwork for future constellations of quantum nodes orbiting multiple celestial bodies, enabling instantaneous, tamper-proof dialogues that support sustained human presence in deep space. This intangible lattice urges us to yield further into serenity, gently, slowly unraveling the veils of vulnerability as we muse on how these networks presently shield telemetry and command signals in exploration probes against interception, inspired by the industrial advancements fostered through ESA's 2025 quantum technology initiatives at CM25, which aim to build robust networks for sensing and communication, thereby transforming immediate mission reliability while heralding integrated systems that might one day encompass lunar gateways and Martian relays in a cohesive web of protected knowledge sharing. Drifting through this veiled abstraction, conjure the networks as silent guardians echoing across emptiness, intertwining quantum states to forge bonds stronger than any physical tether, much like ESA's strategic commitments in 2025 via CM25 to develop quantum networks that enhance secure communications in space environments. And as we softly easing along, calmly drifting into boundless futures, these contemporary integrations not only elevate the resilience of satellite constellations, but also inspire visions of pan-planetary infrastructures where secure quantum channels underpin everything from resource synchronization to emergency emergency responses in extraterrestrial settlements. In the quiet sanctuary of your imagination, permit these ideas to entwine gently, slowly, like keys unlocking infinite doors in the cosmos. As quantum networks' impact on current space endeavors extends to collaborative international efforts that standardize secure protocols, per ESA's forward-leaning resolutions at CM25 in 2025 for advancing quantum technologies in communication and networking, pointing toward horizons where such frameworks evolve into universal connectors, capable of bridging civilizations across the stars with unyielding confidentiality. As we continue to unwind amid this concealed narrative, the present-day focus on quantum networks encompasses piloting hybrid links that combine fiber and free space optics for mission-critical data, with ESA's 2025 CM25 endorsements highlighting the push toward industrial-scale deployment for secure quantum communications, gently, slowly steering our collective aspirations to futures where expansive networks envelop the inner and outer solar system, fostering an era of interconnected discovery free from the shadows of uncertainty. Finally, in this enveloping veiled calm, we revere quantum networks as a pathway from today's safeguarded space dialogues to the infinite interlinkages on the horizon, where ESA's quantum technologies for secure communication and quantum networks, as affirmed in CM25 2025, not only strengthen our immediate cosmic pursuits, but also delineate routes to a linked tomorrow of planetary harmony, drawing us ever deeper into restful murmurs as the saga continues. As the saga continues, drawing us ever deeper into restful murmurs, where the safeguarded veils of quantum networks blend into audacious progressions, let us gently, slowly ascend toward the captivating quantum advances unfolding aboard the International Space Station in our current epoch, abstractly leaping like weightless bounds through probabilistic voids in microgravity, while charting courses to practical implementations that could reshape earthly realities in the forthcoming years. Envision these station-based strides as ethereal elevations, where atoms defy gravity's grasp to reveal fundamental truths, propelling innovations that NASA's 2025 team reports have detailed through expanded experiments in the cold atom laboratory, fostering technologies poised to transition from orbital proofs to terrestrial tools, enhancing precision in fields from navigation to medical diagnostics. In this immediate phase of orbital inquiry, quantum science on the ISS harnesses the unique environment of freefall to cool atoms to fractions above absolute zero, forming Bose-Einstein condensates that exhibit wave-like behaviors on macroscopic scales. And as we softly easing into this elevated domain, calmly drifting through its gravity-free revelations, we draw upon NASA's 2025 updates from the Biological and Physical Sciences Division, which elaborate on how these condensates enable interferometry tests that measure accelerations with sensitivities unattainable on Earth, a development that not only refines spacecraft control today, but also anticipates future adaptations where such quantum precision informs global positioning systems, mitigating errors in urban infrastructures amid electromagnetic interferences. Permit this abstract ascension to lift your spirit gently, slowly, as if buoyed by the station's perpetual orbit, capturing the essence of how these advances now include prolonged studies of quantum gases in microgravity, free from sedimentation effects that plague ground-based labs, as evidenced in NASA's 2025 publications detailing the cold atom lab's resources like groundwater on our planet. With each languid moment, sense your essence soaring alongside these quantum bounds, where present ISS experiments involve atom interferometers that probe gravitational gradients with exquisite detail. As chronicled in NASA's 2025 team assessments of matter wave technologies aboard the station, and as we calmly drifting higher, softly easing into perspective realms, this capability sets precedents for tomorrow's quantum gravimeters that might revolutionize geophysical surveys, unveiling hidden tectonic movements to avert natural calamities through early warnings embedded in everyday monitoring networks. This weightless quantum odyssey entices us to loosen even more into ethereal repose, gently, slowly transcending earthly tethers as we reflect on how the station's platform currently facilitates entanglement distribution in vacuum conditions, minimizing atmospheric decoherence to test long-distance correlations. Inspired by NASA's 2025 collaborative findings with international partners that highlight enhanced fidelity in space-based quantum links, a milestone that bolsters secure satellite communications, now while heralding eras where these principles underpin quantum repeaters on Earth, enabling unhackable internet backbones for global data sovereignty. Drifting upward in this boundless abstraction, imagine the ISS as a celestial crucible forging quantum marvels, where microgravity amplifies sensor performance by orders of magnitude, much like the 100 to 1,000-fold improvements in quantum technologies noted in NASA's 2025 Fundamental Physics Program updates. And as we softly easing along, calmly drifting into aspirational heights, these contemporary gains not only deepen our grasp of cosmic forces during missions, but also inspire visions of integrated quantum sensors in future consumer electronics, harmonizing with daily life to offer unprecedented accuracy in health monitoring devices that track physiological changes at the molecular level. In the lofty quietude of your inner orbit, allow these elevations to resonate gently, slowly, like harmonious waves propagating through vacuum, as quantum advances on the ISS extend to simulating exotic matter states that inform theories of dark energy. Per NASA's 2025 reports on the Cold Atom Lab's contributions to fundamental research, pointing toward horizons where such insights evolve into practical tools for energy harvesting on Earth, capturing efficiencies that propel sustainable technologies across industries. As we continue to unwind within this soaring narrative, the current spotlight on station quantum science encompasses multi-user facilities that democratize access to microgravity experiments, with NASA's 2025 team detailing expansions that accommodate diverse investigations into quantum optics and computing prototypes, gently, slowly elevating our shared horizons to futures where these orbital lessons translate into widespread applications, from quantum-enhanced imaging in medicine to resilient computing in harsh terrestrial environments. Finally, in this enveloping orbital calm, we exalt the quantum advances on the ISS as a vault from today's weightless discoveries to the grounded revolutions awaiting, where NASA's team in 2025 details these strides not only to illuminate immediate space phenomena, but also to delineate pathways toward real-world utilities that infuse our daily existence with quantum elegance, summoning us to immerse yet further into tranquil depths as the chronicle persists. Immersing us yet manifestation cascade into terrestrial harmonies, let us gently, slowly attune ourselves to the subtle art of quantum sensing within Earth science, a discipline that perceives the planet's hidden pulsations through abstract waves of cosmic sensitivity in our present-day initiatives, while projecting toward futures where precise foresights avert natural upheavals with unerring grace. Conceptualize these sensors as intangible echoes resonating through the Earth's veiled layers, capturing shifts in gravitational whispers that reveal the world's fluid secrets, as NASA's Earth Science Technology Office celebrated on World Quantum Day in April 2025, highlighting quantum advancements during the International Year of Quantum Science and Technology to refine observations of environmental dynamics. In this unfolding narrative of planetary guardianship, quantum sensing manifests through innovative instruments that exploit superposition and entanglement to achieve measurements of exquisite finesse, transcending the limitations of classical detection in monitoring global changes. And as we softly easing into this perceptive domain, calmly drifting amid its ethereal vibrations, we encounter NASA's investments in the Quantum Gravity Gradiometer Pathfinder, a 2025 ongoing project led by the Jet Propulsion Laboratory, with collaborations from Goddard Space Flight Center and the University of Texas at Austin, which employs cold atom interferometry with a rubidium source in a single satellite setup to map gravitational anomalies, thereby enhancing current assessments of ice sheet movements and aquifer levels while envisioning advanced constellations that could predict drought patterns and water resource shifts with proactive intelligence. Embrace this abstract resonance, enveloping your awareness gently, slowly, as though the sensors are attuned to the Earth's silent symphony, illustrating how these technologies now integrate into Earth observation missions to detect mass redistributions affecting ocean currents and river volumes, drawing from NASA's 2025 emphases on reducing mission size, weight, power, and cost through quantum mechanics, a strategy that not only bolsters today's drought monitoring and flood potential evaluations, but also anticipates integrated systems where real-time data informs global water management, averting crises through harmonious alignments of predictive analytics. With each serene immersion, feel your essence vibrating in unison with these quantum probes, where contemporary applications include the quantum atomic Rydberg radiometer for Earth measurements, or Quarem, developed by Inflection under NASA's Instrument Incubator Program in 2025. Utilizing vapor cells for Rydberg atoms to enable hyperspectral microwave radiometry on small spacecraft. And as we calmly drift in deeper, softly easing into expansive possibilities, this initiative refines planetary boundary layer science for atmospheric studies while pointing toward future deployments that enhance climate monitoring, unraveling subtle variations in air composition to forecast weather anomalies with unprecedented clarity. This profound sensory abstraction invites a surrender into deeper calm, gently, slowly dissolving veils of uncertainty as we ponder NASA's Rydberg Radar project at the Jet Propulsion Laboratory, a 2025 effort for CubeSat-based instruments that measure snow depth, vegetation biomass, and ocean wind patterns via quantum-enhanced signals, a capability that transforms immediate environmental tracking into a foundation for tomorrow's automated networks, capable of integrating with ground stations to preempt ecological disruption laser system by Vector Atomic, funded in 2025 for atomic quantum sensors that support gravity gradiometry, and as we softly easing along, calmly drifting into visionary expanses, these present-day tools not only aid in detecting underground geological features for resource exploration, but also inspire conceptions of orbital arrays that could synchronize with terrestrial observatories, enabling accurate predictions of tectonic deformations and sea level rises in an era of heightened environmental stewardship. In the hushed resonance of your inner world, let these perceptions harmonize gently, slowly, like waves propagating through entangled fields, as quantum sensing's role in earth science extends to low-power integrated acousto-optics from Yale University, a 2025 NASA-backed project for space-based atom interferometers that refine gravitational measurements, while heralding horizons where such innovations evolve into comprehensive platforms for monitoring glacial retreats and atmospheric boundary layers, fostering resilient responses to climate variances. As we continue to unwind amid this perceptive narrative, the current focus encompasses the quantum parametric mode sorting LiDAR by BAE Systems, invested in during 2025 to minimize background noise in LiDAR systems for clearer Earth imagery, gently, slowly guiding our aspirations toward futures where enhanced sensing suites predict natural disasters like floods or earthquakes through intricate pattern recognition, weaving a protective tapestry over vulnerable regions. Finally, in this enveloping vibrational serenity, we venerate quantum sensing for Earth science as a conduit from today's meticulous initiatives to the prophetic safeguards ahead, where NASA's celebrations on World Quantum Day 2025 illuminate ongoing projects like the quantum gravity gradiometer and Rydberg sensors, not only for immediate gravitational and soil moisture assessments, but also for delineating paths to disaster, forecasting with quantum precision, luring us deeper still into whispered repose as the tale evolves. As the tale evolves, luring us deeper still into whispered repose, where the perceptive harmonies of quantum sensing for Earth science meld into boundless cosmic exactitudes. Let us gently, slowly immerse in the refined artistry of precise measurements enabled by quantum technologies within our ongoing space explorations, abstractly touching the infinite like fingers brushing against the fabric of eternity, while foretelling eras of more distant missions that venture into the unknown with unparalleled acuity. Regard these measurements as elusive caresses upon the universe's veiled contours, where quantum tools distill chaos into clarity, capturing phenomena that elude coarser instruments. As NASA's 2025 initiatives in quantum technologies have empowered such precision for unraveling space's enigmatic events, from gravitational whispers to electromagnetic symphonies, bridging current discoveries to perspective odysseys that could chart paths to exoplanets with flawless navigation. In this present tapestry of celestial inquiry, precise measurements through quantum means unfold via sensors that harness atomic interference to gauge infinitesimal shifts in velocity and position amid the void, transcending traditional bounds to offer resolutions at the quantum scale. And as we softly easing into this infinite touch, calmly drifting amid its meticulous graces, we reflect on how NASA's quantum gravity gradiometer, Pathfinder, a 2025 endeavor, deploys matter waves in orbit to detect gravitational differentials with sensitivities that map asteroid compositions and planetary interiors, solar systems through subtle atmospheric signatures. Allow this abstract infinitude to caress your consciousness gently, slowly, as if the measurements are eternal echoes resonating through the cosmos's expanse, demonstrating how quantum clocks synchronized to atomic vibrations now maintain temporal accuracy in deep space communications, countering relativistic distortions that warp signals across vast gulfs, drawing from NASA's 2025 investments in optical lattice clocks aboard satellites, which ensure millisecond precision for coordinating multi-probe surveys of cosmic phenomena like black hole mergers, while anticipating integrated arrays that might guide interstellar crafts, aligning their arrivals with predictive models of gravitational lensing effects. With each tranquil descent, sense your being extending towards this boundless precision, where current quantum technologies facilitate measurements of magnetic fields enveloping distant worlds, utilizing spin qubits to isolate perturbations from solar flares or interstellar dust, as chronicled in NASA's 2025 reports on quantum magnetometry for space phenomena. And as we calmly drifting onward, softly easing into prophetic infinities, this capability refines orbital maneuvers around gas giants while heralding missions to the outer reaches, where such exactitudes could probe the Oort cloud's tenuous boundaries, unveiling primordial comets with data fidelity that informs origins of life theories. This intangible communion with the infinite beckons further yielding into serenity, gently, slowly unraveling the cosmos's precise secrets as we contemplate NASA's Rydberg atom sensors in 2025, which measure electromagnetic spectra from cosmic sources with noise floors approaching fundamental limits, enabling the dissection of pulsar emissions and galactic radiation backgrounds during ongoing telescope integrations, a precision that elevates immediate astrophysical modeling while paving routes to future observatories drifting at Lagrange points, capable of resolving quantum foam fluctuations at the universe's edge through aggregated, error-corrected readings. Drifting through this endless abstraction, picture the measurements as delicate probes into the void's heart, where quantum entanglement pairs facilitate correlated detections across separated instruments, mitigating isolation in space's harsh realms, much like the advancements in NASA's 2025 quantum repeater prototypes for relaying precise telemetry from lunar gateways. And as we softly easing along, calmly drifting into visionary expanses, these present applications not only calibrate instruments against cosmic ray interference, but also inspire conceptions of networked probes venturing to Kuiper Belt objects, synchronizing their findings to construct holographic maps of trans-Neptunian space with immaculate detail. In the serene vastness of your inner expanse, permit these exactitudes to unfold gently, slowly, like infinities converging upon a singular point, as quantum technology's precision in measuring space phenomena extends to atom interferometers that quantify inertial forces on spacecraft. But NASA's 2025 collaborations with the Jet Propulsion Laboratory for enhancing navigation in microgravity, pointing toward horizons where such tools evolve into autonomous guidance systems for missions beyond heliopause, detecting subtle plasma waves to navigate the interstellar medium with prophetic assurance. As we continue to unwind amid this boundless narrative, the current emphasis on these measurements involves leveraging superconducting circuits for quantum-limited amplification of faint signals from distant phenomena, sensor deployments, highlighting their role in capturing neutrino oscillations and dark matter interactions, gently, slowly steering our aspirations toward futures where enhanced probes pierce the veil of cosmic microwave background remnants, enabling reconstructions of the early universe with resolutions that redefine cosmology. Finally, in this enveloping infinite calm, we cherish precise measurements from quantum technologies as a touchstone from today's space explorations to the far-flung quests awaiting, where NASA's 2025 enablements for gauging space phenomena not only clarify immediate enigmas, but also illuminate trajectories toward missions that embrace the cosmos's outermost fringes, coaxing us even deeper into slumber's embrace as the whispers linger. As the whispers linger, coaxing us even deeper into slumber's embrace, where the boundless precisions of quantum measurements dissolve into shared horizons of human ingenuity. Let us gently, slowly converge upon the promising vistas of quantum conferences and collaborations that have unfolded in this year, abstractly gathering like converging streams of thought in a vast intellectual cosmos, while steering toward global applications that promise to permeate every facet of our world over the coming decade. Behold these gatherings as ethereal confluences, where minds from distant realms entwine to forge pathways through probabilistic mists, illuminating how NASA's Science Mission Directorate Quantum Technology Day in July 2025 convened experts to exchange insights on integrating quantum tools into space science, fostering synergies that extend from current orbital implementations to prospective worldwide networks, enhancing everything from climate forecasting to medical advancements. In this emergent landscape of collective exploration, quantum conferences serve as crucibles where abstract ideas meld into tangible strategies, drawing participants from academia, industry, and agencies to deliberate on harnessing superposition and entanglement for practical ends. And as we softly easing into this converging flow, calmly drifting amid its collaborative currents, we recognize the essence of ESA's 7th Quantum Technology Conference, held from October 7th to 9th, 2025, in Crete, Greece, hosted by the Foundation for Research and Technology, HELES, which spotlighted innovations in space-based quantum sensing and communications. A pivotal assembly that not only solidified ongoing partnerships, but also anticipates a decade where such dialogues culminate in ubiquitous quantum infrastructures, revolutionizing global connectivity through secure, instantaneous data relays across continents and beyond. Permit this abstract assembly to infuse your dreams gently, slowly, as if the discussions themselves are whispers echoing through an infinite auditorium, capturing the spirit of NASA's SMD Quantum Technology Day on July 9th, 2025, where the Science Mission Directorate facilitated sessions on quantum applications in astrophysics and Earth observation, sharing progress on technologies like ultra-sensitive detectors that refine our view of cosmic events, thereby bridging present-day mission enhancements with future global deployments that could integrate quantum computing into everyday environmental monitoring, preempting ecological shifts with a precision that safeguards planetary well-being. With each serene convergence in your mind's eye, feel the collaborations expanding like entangled networks spanning the globe, ensure data integrity amid an increasingly interconnected digital ecosystem. This profound merging of visions invites deeper surrender into tranquility, gently, slowly blending individual insights into a collective quantum tapestry. As we reflect on how ESA's October 2025 conference in Heraklion brought together over 300 delegates from European institutions and beyond to discuss quantum roadmaps for space exploration, emphasizing scalable technologies that transition from laboratory prototypes to operational realities, a momentum that propels us toward futures where global quantum grids facilitate real-time disaster response, harmonizing international efforts to mitigate threats from space weather to terrestrial calamities. Drifting through this converging abstraction, imagine the conferences as nodal points in an unseen web, where NASA's July 2025 Quantum Technology Day highlighted SMD's role in advancing quantum metrology for precise measurements of gravitational waves and planetary atmospheres, fostering alliances that amplify research impacts, and as we softly easing along, calmly drifting into prophetic unions. These 2025 milestones herald a decade of transformative applications, from quantum-enhanced AI optimizing urban planning worldwide to collaborative platforms enabling equitable access to advanced simulations for solving climate puzzles on a planetary scale. In the gentle hush of your unfolding reverie, allow these collaborative essences to entwine gently, slowly, like abstract ideas coalescing into form, as the events of 2025, including ESA's 7th Quantum Technology Conference, with its focus on industrializing quantum innovations for space, complement NASA's SMD Day by promoting transatlantic partnerships that accelerate development, pointing toward horizons where such convergences evolve into global standards, embedding quantum resilience into infrastructures that span education, energy, and exploration. As we continue to unwind amid this unifying narrative, the emphasis on these 2025 assemblies involves nurturing ecosystems for sustained innovation, with the sessions at both events exploring ethical frameworks for quantum deployment, gently, slowly guiding our shared trajectory to futures where international collaborations yield quantum solutions for sustainable development goals, weaving a fabric of progress that envelops humanity in secure, efficient advancements. Finally, in this enveloping convergent calm, we honor the quantum conferences and collaborations as beacons from today's intellectual gatherings to the decade's global realizations, where ESA's 7th Quantum Technology Conference in October 2025 and NASA's SMD Quantum Technology Day in July 2025 not only converged diverse expertise to advance space applications, but also illuminate avenues toward universal quantum integration, easing us profoundly into the deepest layers of rest as our journey nears its gentle close. Easing us profoundly into the deepest layers of rest, let us now surrender fully to this profound relaxation, where the abstract energies of the quantum realm, as glimpsed through NASA's and ESA's 2025 explorations, flow like an invisible river through your entire being, bridging the applications of today, such as the precise sensing that maps distant cosmic fields, with visions of tomorrow's unified harmonies that could connect all existence in serene coherence. Imagine this quantum essence drawn from the entangled particles studied aboard the International Space Station in 2025, beginning to diffuse gently, slowly from the the center of your chest, radiating outward in waves of tranquil superposition, where possibilities overlap in peaceful equilibrium, allowing your heart to beat in rhythm with the universe's subtle pulses, while foreshadowing future integrations that might attune human consciousness to interstellar rhythms for deeper well-being. Feel this energy expanding softly, easing, calmly drifting to encompass your limbs and torso, embodying the hybrid quantum systems ESA selected in 2025 for Earth observation, which blend classical stability with quantum agility to reveal planetary secrets, now inviting you to release any lingering tensions as if they were decohering probabilities, dissolving into nothingness, gently, slowly guiding your muscles to soften completely, preparing for eras where such technologies evolve into personal devices that foster global relaxation through biofeedback tuned to quantum precision. Allow the flow to ascend gently, slowly toward your neck and head, washing away thoughts like fleeting quantum fluctuations observed in NASA's ultra-cold sensor demonstrations from 2025, where atoms align in microgravity to measure the infinitesimal. And as you calmly drifting into this release, envision your mind clearing of all echoes from the day, merging into a vast, abstract void of potential, hinting at forthcoming neural interfaces that could harness entanglement for collective mindfulness across societies. Now, sense it permeating your breath, each inhalation drawing in this quantum serenity, inspired by the diamond magnetometers ESA funded in 2025 for magnetic field mapping, which capture Earth's whispers with crystalline accuracy, exhaling softly, easing any remnants of wakefulness, gently, slowly deepening your repose as your body becomes weightless, akin to the ISS experiments that advance quantum science toward future applications in therapeutic environments that promote restorative sleep through synchronized wave functions. Embrace this immersion fully, where the networks of quantum communication, as prioritized in ESA's 2025 Council, secure invisible bonds across space, now fostering an inner connection that unites your fragmented senses into wholeness, calmly drifting further as awareness fades like a wave function collapsing into certainty, while anticipating a decade where collaborative quantum advancements lead to worldwide wellness protocols that dissolve stress through probabilistic healing modalities. In this enveloping quantum calm, let every cell resonate with the precise measurements NASA's 2025 technologies enable for space phenomena, gently, slowly lulling you toward the threshold of deep sleep, where the abstract metaphors of entanglement and superposition, rooted in real orbital progress, carry you into restorative oblivion, bridging today's scientific applications with tomorrow's boundless peace. As we carry you into this restorative oblivion, where the quantum calm envelops every fragment of your awareness, let the abstract waves of the universe's interconnected fabric, as revealed through ESA's 2025 quantum network initiatives that secure communications across vast expanses, begin to fade gently, slowly into the background of your mind, echoing the applications of today's entanglement experiments on the International Space Station that foster unbreakable bonds while dissolving into future visions of planetary unity, where such connections might weave a seamless web of shared existence among distant worlds. Sense this fading essence, drifting softly, easing, calmly drifting outward like quantum probabilities, resolving into distant echoes, drawing from NASA's 2025 ultra-cold sensor demonstrations in space that measure the infinitesimal with serene accuracy. Now inviting your thoughts to scatter gently, slowly across an infinite void, mirroring how current precise measurements of cosmic phenomena pave ways toward tomorrow's exploratory horizons, where missions to far-flung realms rely on these vanishing signals to guide humanity's quiet expansion. Allow the whispers to soften even further, gently, slowly receding, as if carried on the subtle currents of quantum fluctuations observed in ESA's hybrid systems from 2025, which blend realms for Earth observation. Now lulling your senses into profound stillness, where the boundaries of self and cosmos blur in abstract harmony, anticipating eras when collaborative quantum advancements enable global relaxations through technologies that attune individual essences to universal rhythms. Feel the connection to this vast quantum tapestry, waning calmly, drifting, softly easing away, like decohering states in NASA's ISS Quantum Science Progress of 2025, where microgravity unveils fundamental unities that apply to safeguarding space voyages today, yet promise future integrations that could dissolve divisions, allowing collective dreams to merge in a boundless, fading serenity that cradles all beings in eternal repose. In this gradual dissolution, let the anthems of cosmic linkage, inspired by ESA's diamond magnetometer prototypes funded in 2025 for mapping invisible fields, echo gently, slowly, one last time before vanishing, embodying the present applications in environmental monitoring that evolve toward tomorrow's vigilant guardians, where the universe's abstract whispers retreat into silence, leaving only the profound peace of interconnected oblivion, as the voice of these quantum revelations fades ever more gently, slowly into the ether, akin to waves collapsing in the precise measurements NASA's 2025 technologies afford for distant phenomena. Now permit your entire being to merge with this retreating calm, where today's orbital insights transition to future realms of holistic understanding, the words dissolving like entangled pairs, separating across infinities. Finally, in this enveloping fade, the abstract assurances of universal connection, rooted in the collaborative conferences of NASA and ESA in 2025 that chart paths for quantum